So when we were dealing with the sum of a sequence in the two formulas we had, those were sum of finite sequences, but we can have infinite ones. So if we have an infinite series, it could be written like this, either way, in the summation notation format or the list with the ... at the end. An infinite series converges if it has a finite sum S. So even though it's an infinite series, we can actually have a finite sum. If an infinite series doesn't have a finite sum, then it diverges. All right, so we said sometimes infinite geometric series have a sum, and again, that means that it converges. So the geometric series, now be careful, it wrote it like this on the computer, but it still is in summation notation from k equals 1 to infinity. And here is our geometric series. Okay, this geometric series converges if and only if the r, actually the absolute value of r, or the absolute value of the common ratio is less than 1. And if it does converge, then the sum is a over 1 minus r. All right, so we're going to use that formula. Now, I do want you to point out that it does specifically have, it doesn't just say a sub k next to this, in this summation notation, it has this specific equation. So if it's not in that form, then to find a and r, we'd have to maybe do some other work. But if you notice the a, when it's in this form, the a is the first term. All right, so let's use that. All right, so let's determine whether the series converges. If it converges, we're going to give the sum. So again, I need the infinite geometric series to look like this. All right, so if you take a look at A, we're going to know if it converges if the R, the common ratio or common quotient, absolute value of it is less than 1. So we can see that the R is 0.75. So 0.75 is less than 1. Okay, so that means it converges. And it says if it does converge, then we have to give the sum. So the sum was a over 1 minus r. All right, so a was 3. And again, it's because it looks exactly like the form. Over 1 minus r was 0.75. So if we find that value, we will find that it is 12. So if you were to write out this sum, or this series, and find its first term, and we know it's 3, find its second term, and third, and fourth, and fifth, and we'd write it out as far as we can. Eventually, right, its sum would be 12. Now that's really more like a limit because we can't go out to infinity. It keeps going and going and going, but it converges to its sum of 12. Okay, so let's take a look at the next one. Again, sorry about this notation. The computer just did that. All right, now notice this doesn't look like a times r to the k minus 1. But we definitely can tell that the ratio is negative 4/5. That's what we're multiplying by. So we'll use that. So the absolute value of negative 4/5 is 4/5, and we know that that is less than 1. so that we know this converges. And since it does, we're supposed to find the sum, which is a over 1 minus r. Now remember, a is our first term, or it's this term written in this form, but I don't have that. So if I were to plug in 0 to find my first term, anything to the 0 power is 1. So I'm going to do 1 over 1 minus negative 4/5. That's r. So my sum is 5/9. All right, let's try C. We're starting at n equals 1. We're going to infinity of pi over 2 to the n power. My r, we're still multiplying by pi over 2. I know, again, it's not in that form, but that's still what we're multiplying by. And we check to see if absolute value of pi over 2, which is still positive, is less than 1. And if you check pi over 2, it's actually greater than 1. So this does not converge. This diverges. All right. So our last one here is not written in summation notation. So we might have to find a few things. So first off, we need to know what r equals. So what are we multiplying by? So it looks to me like we're multiplying by 1/2 each time. And 1/2 is less than 1, which means it converges. That means that this infinite series is going to have a finite sum, and that sum is a over 1 minus r. And a at the top is just a sub 1, so it's 1 over 1 minus r is 1/2. So that means the sum of this infinite series, geometric series, is 2 when we find that value.